Hi, everybody. Welcome. I'm glad to see all of you here. For a few of you who don't know me, I'm Lee Spector, computer science professor here. And before I introduce our speaker, I want to say a little bit about ILA, AI and Liberal Arts, which is sponsoring this event. So the premise of AI is that nobody in the world these days should be oblivious to what's happening in AI in terms of the opportunities it provides or the very real dangers it presents. It is permeating our world, and to be an educated person, in my view, you really have to have some clue what's going on, and I think engage with it from whatever perspective you are coming from. So what ILA tries to do is to provide a vehicle for everybody across the curriculum, including computer scientists, but very much also including non-computer scientists, to engage with AI and in all of its dimensions. One of the things we do is bring speakers, like today's speaker, but we also do other things. We have a website, liberal-arts.ai, which I strongly encourage everybody to check out. And one of the things there is interactive forum, to which you are very much encouraged to contribute. And there is a page there for this event, and you can add comments or questions to that thread. You can also start your own threads about comments or questions you have about anything related to AI. There's a lot of other stuff there. There's sort of brief summaries and pointers to a bunch of recent news stories related to AI that we think would be of interest to the community. There are tutorials that are developed for using AI tools of various levels of difficulty. So some are completely usable by anybody, and some require coding, but we try to provide an interface to that for people across the curriculum and across the community. So please check that out. Let me tell you about a couple other upcoming ILA events. Thursday, 2 days from now, big event. 6:30 p.m. in Converse Hall in the Cole Assembly Room, also known as the Red Room, is an event on AI and war, a panel discussion. Some real heavy-hitting expertise on this topic, including Amherst professors and visitors that we're bringing in. I'm extremely excited about this because it's a really, really important topic that I think everybody should know more about. So that'll be at 6:30, and there'll be refreshments. That'll probably be about an hour-and-a-half event. Also coming up, another very exciting event. Actually, the person who's going to be doing this event is on campus today, visiting in on a theater and dance class, but will be performing at the Powerhouse at a dance performance on April 27th at 7 p.m. This is Mariel Petit, who is a particle physicist and a dancer, who during the beginning of the pandemic couldn't interact with other dancers, so turned the machine learning models that she was using for physics on her body to learn about things about her physical movement, and has developed a whole dance practice around it, and is bringing a bunch of fellow dancers to do a performance that we're all extremely excited about. Powerhouse on the 27th of April at 7 p.m. Okay, so I hope that you will attend those events as well. Now, let me say a little bit about our speaker. Brendan O'Connor is an associate professor in the College of Information and Computer Sciences at University of Massachusetts Amherst. He works at the intersection of computational social science and natural language processing, studying how social factors influence language technologies and how to better understand social trends with text analysis. For example, he has investigated racial bias in natural language processing technologies, political events reported in the news, and language on Twitter. He's a recipient of the NSF Career and Google Faculty Research Awards. He's received Best Paper Awards, and his research has been cited thousands of times and been featured in the media. At UMass Amherst, he is an associate director of the Computational Social Science Institute, which, let me pause to say, does amazing stuff and has amazing speakers, and you should get on their mailing list because that's really cool stuff. Brendan's PhD was completed in 2014 from Carnegie Mellon University's Machine Learning Department, and he's previously been a visiting fellow at the Harvard Institute of Quantitative Social Science and worked excuse me, lost my place here, and worked in the Facebook data science group and at the company Crowdflower. He started studying the intersection of AI and social science in symbolic systems at Stanford University. And with that, let me just say the plan is to be done at around 5:30, maybe a few minutes after that. And so I've asked Brendan to talk for 40, 45 minutes and allow a little bit of time for Q&A. All right, take it away, Brendan.
All right. All right. All right, thanks so much, Lee. Thanks for organizing this. Thanks for the invitation. Really sorry to Morgan and folks for doing a late abstract. I know it's annoying. You have bad speakers. But it's really exciting to be talking about artificial intelligence and the liberal arts. So just because I'm new to visiting here, I was wondering what majors are people from? Someone from, I don't know, computer science? A few? Is there any other major? I guess you just say. I don't know how many, do we have any other majors? Want to say something? English. Oh, great. Political science. Great. Philosophy. Hello. Theater and dance. All right. Linguistics and CS. A great combination. Love it. Any other? Sorry? Economics. Great. Psychology. All right. Psychology. All right. So this is all great stuff. My own major was a cognitive science sort of major. It was officially called Mixture of Computer Science, Philosophy, Linguistics, and Psychology. These things, of course, intermingle in all sorts of great and complicated ways. And a liberal arts perspective, I think, is a really useful, really great way to understand computation and address some of it. It's just, you have to intermix it with the technical issues, of course, and exactly how to do that and when can be very important. And I'm going to argue today, the technical issues are extremely intertwined in ways that are quite important for the technologies, how we might use them, and how we kind of think about in the relationship to social investigation. So, all right, I have a quote from a news article about NLP research. When I listen to it and see if you can give me a guess about where this might come from. So last week, there's a demonstration of a new system that's going to be the first non-living mechanism able to perceive, recognize, and identify its surroundings without human training or control. This device will think as the first human brain. Like humans, it will make mistakes at first, but will grow wiser with experience. The only step left of its development, a difficult step, is needed for the device to hear speech and translate it, and to instantly translate it from one language into another. All right, so that's the New York Times I just quoted. Any guess what it might be about? Sure. Yeah, technologies like ChatGPT seems reasonable. Anything else it could be? I don't know, robots and wars or something? No? All right, so yeah, I mean, it sure sounds like things that have been this, we've had this very breathless wave of media hype, intellectual revolution from ChatGPT, philosophical challenge not experienced since the start of the Enlightenment. We're going for a strong hypothesis here. But the quote actually is from 1958, the New York Times. I paraphrased a little bit. I took out mentions of the word Navy because we no longer associate the Navy with cutting-edge artificial intelligence. Maybe we should. I don't know. But yeah, the Navy last week demonstrated this thing at the Cornell Aeronautics Laboratory by Frank Rosenblatt, who we now know as a researcher who invented the perceptron learning algorithm, one of the most fundamental or basic algorithms of machine learning to learn and adapt from experience. And they had big ambitions for this. It's going to have around 1,000 electronic association cells. Not as many as in the eye, but it's going to learn things and gain experience. And so this is from the, I guess, post-war era of artificial intelligence research in the United States, when people were very excited about making really intelligent machines. And of course, we know that in that era maybe it didn't work or didn't work as well as the systems we have today. But these worries or thinking about artificial intelligence, we've been here before. And of course, just the latest over the last several months is all of these. You see a talk like this in a year, maybe we'll have something new to talk about again also. So sorry if you're sick of these ChatGPT screenshots. I noticed on the website there was some mention, so I'm just assuming everyone is familiar. I don't know. Has anyone used ChatGPT or these other systems? Quite a few? Yeah? Okay, sounds good. All right, so you write stuff in, and stuff comes out, and, remarkably, it generates language that sometimes follows the instructions. It can sometimes do things that look like reasoning. It often does things that are not so logical. It sounds confident and smart, so there's something going on. And this isn't the only thing to do in natural language processing. In general, natural language processing is the art and science of computational understanding or just processing of language, including text, maybe including related things like speech. But it is one example that is becoming increasingly common, and it does illustrate a lot of the issues of how social issues or the social sciences are embedded in these sorts of systems. If you're following the stuff or interested in it, I don't know, this area, there's always like a new paper posted on arXiv in the last week. So here's a new paper posted on arXiv last week. I thought it was actually a pretty useful review, a lot of the technical, say, limitations or state of knowledge about ChatGPT or other models and the class of things called large language models. They're models that can generate text, or on a technical level, they define a probability distribution or strings of words. And so we have these interesting things about large LMs that are quite surprising compared to what researchers in NLP like myself would have thought 5 years ago. We have some cases, for example, large language models are trained on lots of data. They keep getting more capable when we increase the investment. Larger data sets, larger amounts of training, engineering, more work on these things. They are really increasing their information processing capabilities. Whether you call it intelligence or not is another question, but there's no question there are improvements in the, emulating human behavior, emulating human intelligence. And there's even remarkable things about, they seem to capture representations of the outside world, which is very remarkable since these are based on artificial neural networks with no explicit representations of things like that. On the other hand, we basically know nothing or very, very little about lots of the most important things about how they work and what we might expect from them. The behaviors that are really cool, they emerge very unpredictably as a byproduct of increased investment. We don't have any reliable techniques to steer their behavior. There are some things that kind of work sometimes. We can't interpret the inner workings of them. And they don't necessarily express things like values in the way that you might want them to, if you're interested in generating text that might be reasonable. And the thing is, if you think about like some of these, at least these ones, we can say these things, we have this lack of control, lack of knowledge over large language models. I would argue there are other agents we might say these things for. I think it's not crazy to say it's not clear if there are reliable techniques to steer the behavior of people. I don't know. I have a 4-year-old. There's lots of behaviors I would like him to do. I do not have reliable methods to do this. Experts may not yet be able to interpret the inner workings of people, the inner workings of a mind, the inner workings of a social system. You can study a major in psychology and learn a lot about it. You may not fully be able to interpret what's going on inside someone's head. It's quite reasonable, right? This is a fundamental problem. People may not express the values of, say, from their education or their caregivers. I don't read a lot of ethical stuff in philosophy class. Are you going to be ethical later? It's unclear, right? In brief interactions with people, trying to assess what they're thinking, what they're doing, those could be very misleading. Small n, you don't get representative samples. It's maybe not a surprise that we're creating artificial intelligence systems that are unknowable or difficult to understand for really the same reasons people are difficult to understand. Cognitive sciences or social sciences are just challenging areas in general. So, all right, so for this talk, feel free to jump in with questions. I just want to lead off with language models and things like that. But at any time, if you have a question or something interesting to say, please go ahead. We don't really have to go through these slides or anything. Yes? Oh yeah, the pause for development, yes. So I don't have strong stances on these sorts of pause is just a dramatic thing. I think it's definitely the case that rushing to deployment of a model that conceivably could have significant impact. So for example, people worried about, language model generation to create more spam or misinformation or something like that. That seems like a reasonable concern. I don't know if it's, AI is destroying humanity tomorrow, but real concerns about some application areas. And at least some of the companies working on this are rushing very quickly, and I think really far outpacing these, what's known. And the researchers at the companies, they all know this. There's some confluence of business incentives or whatever the reasons are that they're pushing towards these things it seems a little extreme right now. So being careful and more wise about deploying would be good. Another thing, I have this mentioned later, I'll say it now, is there's a lot of confusion about the difference between research or just broader experiments or development. There's a view that, well, if you're doing research, if you want something to be publicly, you have to make something publicly accessible so other researchers could access it and investigate it. And so I agree with that to a certain extent as someone who would like to access and download these models, and sometimes I can, sometimes I can't. That's very important. But at the same time, we're in a situation where if it's literally anyone in the world can get access to it for free, that may not be the appropriate level of access, especially for some really early stage thing, which can do some nasty things sometimes. And so right now we've lost any distinction between, say, academic research or research in maybe a moderate risk area, as opposed to just unconstrained, let anyone use it for whatever purpose. And so I think these things are all confused right now, and I think there's, pausing doesn't seem like pausing seems like a reasonable thing to do, but something with more care, I think, could be useful, I think. Yeah, anything else right now? Yeah, another one? Sorry, yeah. Oh, that's very complicated. Hold on to that. So what we're going to do is I'm going to talk about the kind of high-level relationships to this, and then we'll talk a bit more about how large LLMs are designed, so we can explore some of these things. Sorry, you had a question?
I just have a request. If
Yes.
you don't mind repeating the question.
Oh, of course, of course.
I'm interested in watching your video later.
Oh, okay, I'm sorry, I forgot about that. Yes, great point, great point. Yes, more LMs are coming up is the summary. Sorry, there's another one? No? Okay. All right. All right, so people are hard to study, and we're in a situation we've created artificial intelligences or whatever we think language models are. They're also hard to study. And so we're in this situation, I believe, because social factors really affect artificial intelligence, or specifically natural language processing is what I actually know about, and any computational models of human intelligence. And our behaviors and cognition and language and things like that are all embedded in a whole variety of social factors, social structures, social processes. We might think of indicators that are maybe like demographics and gender ethnicity that we might have, how we interact with each other, what's our cultures, what's our institutions, organizations, things like that. These factors all heavily, heavily influence what sorts of artificial intelligence we're going to get out, whether the domain is language, whether the domain is vision. We're thinking about how these models might represent information, might create decisions, might utilize language, or be able to do computational vision in different ways. And so first part of this talk or discussion, I want to talk about how social factors can affect natural language processing. And then second, I'll talk about some examples of how natural language processing could help us learn about society. So to go backwards and say, okay, well, if we don't want to worry about AI for a second, maybe we can get some use of this for the purposes of the social sciences or research about society. Okay? All right. Okay, so DGP, data generation process. It's important to think about where we get all this textual data that we see. The textual data is going to be used to train all of these natural language processing models. And of course be useful for us. And so if you think about there's a process that generates the data. If we think about it, it's deeply socially embedded. There's people, say society at some grand level, or maybe just a pair of people having a conversation, people interacting, people are communicating. There's some sort of writing process. This can look at very different eras or media systems. And finally, we get some sort of textual data, written corpora. This textual data is really key linchpin of all NLP technologies. And here is the training pipeline for ChatGPT and similar. More specifically, it's called the instruction fine-tuned language models from approximately a year ago. For these things, it's hard to stay up to date with all the changes. But there's a first training phase for what's called for a language model. This is a neural network model that, on a technical level, gives you a probability distribution over strings of words. The sentence, my name is Brendan, might be pretty probable, but name Brendan, my is less probable. It violates grammatical constraints of English. But if you think about probabilities of words or sentences or paragraphs in general, there's lots and lots of things that are more likely or less likely. You might have crazy shifts in topic. How was the weather today? Like, that was unlikely in this sort of context, right? You might have radical shifts in the author's mood or something like that. You might have references to things in the world, but you're not coherent. You just introduced new actors who weren't there before. And so there's lots and lots of different linguistic or communication factors that goes in to this very technical, some ways simple problem of predicting the probabilities of words in text. So this is called language models. And when you run something like ChatGPT, it's spitting out random samples from its language model. It's probability distribution over words or sequences of words that run in a row. And so the first step for making these things is to tune the parameters of the neural network language model to maximize the probability of the words in the corpus, or specifically the strings, the sentences, the paragraphs, et cetera, the corpus. The current they're called large language models. I guess it means a large number of parameters. I would argue the fact they're on a large amount of text is pretty important. The current ones are trained on typically not like trillions of words or so. For the ones in English, at least, English is the language with the highest amount of data typically. They're using, crawls over everything on the web. They're using large corpora of books. They might be using in copyright books with unclear intellectual property rights that they're doing, government reports, just all sorts of stuff. They typically go for a high quantity. They're less interested in the curation side, at least the current companies doing this are. We have very large corpus, and the hope is, or the hypothesis I think has been borne out the data is if you're able to train a neural network on a very large amount of data, the network starts displaying some pretty surprising emergent behavior in its ability to track things like grammar, syntax, certain aspects of text meaning. And many of you have seen ChatGPT, it's not perfect, but it sure is quite good compared to other approaches you've never used because they're not very good. And you only learn like week 1 of NLP class, and you don't use them again. So it's quite remarkable, but you maximize the probability of these things. Get the language model parameters. Think about this as like a gigabyte of numbers, of parameters of a neural network, artificial neural network. What's an artificial neural network? It's just like a really big function. It's just math. It's a function. You multiply things, you add things, and then when numbers are negative, you bring them up to 0. And then you do it a whole bunch of times, and there's a mechanism to draw information from the vectors, the lists of numbers that are at other recent positions in the sentence or the paragraph. There's a few things like that. There's a lot of neural network architectures. There's one that is extremely popular now that's used in all of these called the transformers. No one really knows why it works well, but people are using it. Great. All right, so we train this on trillions of tokens. You get the language model parameters. If you're in kind of the world of these OpenAI models, something called GPT-2 or GPT-3 that directly follow just this. These models are a lot more interesting now, now that there's a second stage of training called human feedback learning, where if you train just on this, you'll get kind of weird output, you'll get nonsensical things, you'll get really horrifying bad content also. But what you can do to improve things is to use collect good old-fashioned human labels. So in the second phase, you collect, it's unclear, maybe tens of thousands, maybe 100,000s of ratings of textual outputs of saying, here's an example where someone tried to give an instruction to the language model spit something out. Was the paragraph it spit out, was it helpful or not? Was it sexist or not, et cetera, et cetera, et cetera. Yes?
Yeah, isn't that what they have in the current, like, ChatGPT, like, when it gives you a response and say it was, like, helpful?
Yes, exactly. I should include pictures. Yeah, so ChatGPT is giving you, the user, the ability to say thumbs up and thumbs down. They're stealing your data. They're not paying you for it. Don't do it. I don't know, maybe do it. It sounds like fun. So they collect this, but to really make these things work, the best data is to pay a lot of people to collect them. Ideally, people who have training or can be trained for this in various ways. I'll talk about this in a second. But that is labeled, and there's a second training phase to basically make more likely textual output sentences, paragraphs that are have high quality ratings on various dimensions. And this one is what is, I think, a really key thing that was inside the original ChatGPT release. Without it, I think it would have been much less compelling. But they happen to have these things together, and they put a user interface, and now we've all heard about it. And so just to get some idea of what they're doing in these things, here's the labeler collected metadata based on the last year's paper. I'm sure it's different now in various ways. If you look in the appendixes of some of these papers coming out from OpenAI and the large companies, the examples are just like really horrifying. These things all come out of a raw language model, and they collect data to identify when humans look at the text, say when it happens, say when it doesn't happen, and then in the second phase of training to discourage the bad things. The harmful advice, I mean, it's very easy to imagine really bad harmful advice comes out of these things. It totally can happen. Yeah?
What is hallucination?
Oh, hallucination. This is a new term of art. It means when the model really just makes up stuff that is not true or deeply contradictory, not following the truth values of the propositions from the original text. There's a lot of different versions of this. One famous one is like, if you ask it about a real world person, it will just like make up crazy things about that person. It will make up things that we typically might consider bad and illegal to do if a person was communicating about it. Even things like URLs. So the models are creating, I said words, but really it's usually sometimes fragments of words. They can really just generate URLs, just a probability distribution of washingtonpost.com/blah, blah, 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 blah. And it makes up URLs that look reasonable for how we think URLs for web pages are, but they have no connection to reality. You could imagine a smart assistant that like filters them or does something, but at least the system you can use right now don't do that. So the term hallucination is used for this very broad set of things. Because sometimes language model tells you factual things about, I don't know, COVID vaccines have these benefits or whatever, but it could totally make up crazy stuff. That crazy stuff may or may not be supported by, knowledge communities of humans, but funny things can happen for sure. A more straightforward example is if you ask a question about a document and just makes up new things that weren't in the document. That's more like a reading comprehension problem. The term hallucination is used for that too. Yeah, so there's no restrictions. It's amazing that it ever is truthful because the way the model is organized, I could write the math, but the math won't help because the math does not have any terms for like what is true, what are the semantic propositions, and nothing like that. It's really just predicting words. It often predicts words in ways that are coherent based on the input, but there's no guarantee. I don't know if that's helpful. Yes? Oh yeah, just think about every most horrible racist thing you could think about different groups, or not necessarily racial groups, other groups, people with disabilities, anything. They'll just generate all that, right? Yep. Taking the data from, so the question is that from taking the data from all the internet, yeah, you get that stuff. Some of us wonder if they could do a better job at the data curation or cleaning step. This is one of a list of endless research questions about LLMs that I think have not been adequately explored right now. And there's a lot of hypotheses, right? Maybe the nature of human cognition and linguistic behavior is such that even when your corpus is clean and formal and nice, there's this like evil lurking underneath humanity, and the bad stuff will come out, right? I think it's a fun research hypothesis. I don't know if that's true, but no one's done that experiment. in part because the research infrastructure you need to do these experiments is actually quite challenging, I think. Not a lot of institutions can do it right now. Yeah?
Does it go to become as objective as possible, or try to develop this kind of whole like personal opinions?
So the question is the goal to be as objective as possible or to give personal opinions? The goal is unclear. It's just like software. I don't know. What does the company want? They want people to use it? Sorry.
The goal is money.
The goal is money. Yes. I used capitalism in my abstract. I was like, oh man, do I know much about capitalism? But it's pretty clear. I mean, realistically, like you can imagine, for example, one of my colleagues, Professor Mohit Iyer, works on creative language. And so tools that might assist, for example, a fiction author in writing, which case is not exactly truthfulness is your goal, but coherency might be a sort of a goal. But you could also imagine a tool that does things that are more like traditional Google, gives you high accurate information for something. That's totally a thing you could tune LLMs for. They sometimes do it. They're imperfect. It's unclear whether they're a great tool to use right now, but those could be your goals. And I think another big confusion about this stuff, it's almost purely technical. Like this slide is boring, who cares, right? But even the definition of large language model is really just this purely technical definition. And I think we have chatbots. It's unclear what the purpose of a chatbot is, right? You know, a chatbot lets you cheat on homework. Okay, that's a real goal. You could think about trying to optimize that in various ways. But it's an accident that ChatGPT can even do that at all. So that's what's very weird about this, is technology where the applications are unclear, but it seems like it has a lot of power, and so it's interesting to explore the applications, call it research or, I don't know, product development or whatever it is. But these things just all kind of go together. And so it's, I don't know, a tool searching for problems. And this is typically kind of a bad thing from bad computer science that I've certainly been guilty of. Like, I have this cool technical tool, I want to do something cool with it. But I would argue large language models are an impressive technical tool, even if we still don't always know what to do with it. Yeah?
Are they taking in metadata, for example, books and how to trust, some of them are labeled fiction, for example?
Are they using metadata? Yeah.
I mean,
Fiction versus nonfiction. They do not always talk about that in the details when they release papers about this. We don't know. You can imagine that could be a good thing. It really depends on your application. Like maybe you want a question answering system for a particular fictional world, right? And then, you know, fictional worlds are often very important for humans. Maybe you want a question answering system based on certain core religious texts of major religions. That's not something you want to throw away. It seems like a significant cultural aspect of humanity that, you know, you might want to be able to do intelligent processing with. So it's, I don't know, maybe that's I don't know, but there's.
let's think about historical novels.
Historical.
Filled with hallucinations about, real people, right?
Oh yeah, so in our text, the humans are hallucinating about each other, right? A historical novel that's hallucinations about people. Yeah, sure, of course. Yeah, I don't know. Are things in history books true? I don't know. It's a complicated, really complicated questions, right? Maybe it's refreshing. We have computational models that violate all the things that we think should be truthful. So we have a chance to think about some of these. I don't know. Okay. Sorry. Going on forever. Of course, labels are hard to collect. So there's reporting on this, and from lots of other major efforts of collecting the human labels in these settings can be very traumatizing. Depends what the output is. You saw those labels there. Imagine reading through hundreds or thousands of these and trying to rate them. Imagine the ratings that are the worst possible on axes of abuse or other factors. It's very hard. How do you do even fair labor in that setting? It's unclear. And this step of this data collection, I'm arguing, is extremely, extremely important in how all these systems are set up. And human labeled collection of doing these sorts of ratings is laboriously over many items, maybe with great trauma or maybe not in more benign areas. It's super important for history of machine learning in general. This human behavioral data, in particular what's called annotation or labeling, super important. And so just think about just computational vision. So the first thing I showed from 1957, it was an early vision system called the perceptron. It actually didn't work very well, despite all the media hype, right? more sophisticated version of this model called convolutional neural network came back in the 1980s. This is called the second wave. I call this the second wave of neural network research. Something's called connectionism. There's a lot of excitement about these artificial neural nets. It has more sophisticated architecture, do things like recognize digits. It worked better. They had a better model for it, but again, hit limitations eventually. People got less interested in it. Finally, much more recently, about 10 years ago, in the area of computational vision, especially for recognizing different types of objects, there was developed ImageNet. It's a data set of millions of images drawn from the internet that have been labeled by people. They used crowdsourcing, crowd workers. Amazon's Mechanical Turk, I believe, was used for a lot of it, maybe all of it. And this allowed basically the same model from 1989 to suddenly start working. There were some technical changes, but it was fundamentally the very same insights, the very same sort of modeling, computational vision, modeling technology. And that really revolutionized computational vision, and it's led to the explosion of neural network research and artificial intelligence in general over the last 10 years, including language, which we just talked about. And so human labeling, I think, is really key. Larger computers are important too, of course. You need those also. But you need the human data collection. You need all these things. Okay. All right. Maybe I'll just wrap up this section of the talk, and we can have even more time for questions. I'm happy to talk about other things briefly. So does someone have a question now? Oh, yes.
I'll wait for the slide.
Okay. Let's see. Okay, so our machine learning-based natural language processing has always come from annotated data and records of linguistic output. And so if you think about what's going to be in these textual corpora, you're going to have just records of how linguistic communication goes between people in a single book and social media posts, all sorts of things. These are all records of human behavior with clues about human cognition or things like that. There's a lot of questions at maybe the social level about what this data is. This data that comes from humans. Whose behavior does it represent? Like the worst people on Reddit, is that training data? Well, it is in at least some of the research papers for some of the large LLMs that have been developed. What values or goals lie behind the data generation or collection? When you think about how the people are behaving or how the data is collected, how may you pay people or don't pay people for data. If the thumbs up, thumbs down things that OpenAI is collecting, they're not paying you for it. You can decide what do you think of the values of that. And I think also crucially, what languages or cultures are represented. We have a lot of focus on English right now, and some of these systems do cross over to multilingual settings, which is very cool. But a lot of it is very data dependent, and we have very different situations for different languages, including important ones around the world. And so if you just think about the language resources that are available, here's a graph of the different Wikipedias. Wikipedia is often used in this type of research. It's not the only one of the very large LMs, of course, but it's kind of a pretty key one. It's reasonably representative of the sorts of data that you can expect. On the y-axis is the number of Wikipedia articles for that language. Here's English. On the x-axis is the number of speakers in the world. And lots of languages, a lot of people speak. The same number of people speak Hindi as English. The Hindi Wikipedia, at least at the time when I downloaded this data, is just very, very small. If it's that much smaller, things like large language models or other types of machine learning trained technology are going to work a lot less well, even for just the raw, how accurate is it sorts of things. This is huge, huge differences. And never mind something like a minority language dialect or a language variety that maybe doesn't have a really consistent writing systems or spelling standards that are mainstream. Or languages or endangered languages with a small number of speakers, just many, many, many settings. Really important aspects of human language and culture are not recorded well, and they're really not going to be usable for these styles of machine learned NLP systems. Someone have a question? No, okay. Oh, yes.
So, yeah, I'm glad I made it for the slide. I was wondering whether, given where LLMs are, like at the stage of the research where they are, because it is just huge, huge data set, right?
Mm-hmm. Just huge data sets, yeah.
It only makes sense that even if there is some work done on metadata, the categorization has not happened. So there's just going to be so much information there that will include sexual, racist, and all these kinds of things. And I was actually in my mind trying to think of an analogy between that and language translation, how it has evolved. So when they started machine learning and translation, it was only phrases or words, and so the translation
Yeah.
was not so good till they came up to the transformative models.
Sure,
where
yeah.
we can understand the linguistic and cultural context and see things more cohesively. So do you think that we are still at a very early stage where our expectations are maybe a bit off? I mean, I'm setting aside the thing that maybe it's a mercenary initiative, but just to think about where LLMs are right now, and for us to expect that already it should be some sanitized version of information. All we are doing is extracting some subsets of it.
Yeah, so you're saying we're maybe expecting too much because all we're doing is extracting subsets of data. It's very tricky. It's hard to even know if what we're doing is reasonable to say is extractive. The neural LLMs from, say, 3 years ago, I would say were pretty nonsensical, but they sounded really good. And it sure seemed like they were, stitching together phrases and sentences from the internet, but stitching together in very nice ways. I think it's a reasonable description of, say, GPT-2 or something like that. I'm less sure that's a good way to describe the very newest ones, where they're getting a lot more coherency about things that you could call, I don't know if facts are the right word, but propositions or intents, or definitely style at the very least, that's coming from these things. And I think it's really unclear. The information is all mixed up in the parameters of a large neural network. We don't know which information is where. There are really cool research trajectories to change that. So for example, make a language model that's specialized to a particular set of documents. Well, maybe you could use metadata, constrain which documents you want to draw information from, for example. That looks more like traditional non-LLM NLP, so I like it. But there's lots of possibilities out there. But I think it's just really not known. And there is this thing that is true, that we can train on more data, capabilities at the level, say, syntax and semantics do get better, typically. And so there's a lot of interest in exploring that, which is not crazy, I think. But we are going to hit diminishing returns. We're going to start running out of data that humans actually generated, is my opinion. I don't know. There's a lot of questions about what is the total size of the cultural heritage of all humanity, right? It's difficult to assess that. Some people work on this. It's super important. If you're interested in the data collection issue for corpora, I highly recommend a paper by So and Gebru on data curation for machine learning. It's an excellent paper looking at this kind of style of thinking about these problems, which has not always been done in a lot of the research, I think. Yeah.
How do you spell that? The researcher's name?
I think the first one's last name So and Gebru. The second author is Timnit Gebru, who's a very well-known researcher in this area. I forget that. I can try to find it for you afterwards if you want.
GEBRU,
GEBRU. Yep, absolutely.
known for being fired, like, for doing this work,
Yeah. Wrote an important paper in the area.
or objecting how it's being used.
Yeah, God. It's been a long time since then. Maybe we should close up. Questions?
Well, we are at about 20 after. I just didn't know if there were any major parts of this you want.
I'll just do maybe 2 more slides after this. I'll keep it simple. Yeah.
I'm wondering if there's like different approaches to NLP based on like the different languages that you use, because I'm noticing like there's English up here and then there's Chinese down here, and
Yeah,
I'm wondering
yeah.
like I've seen like machine learning papers that like they kind of have to take English and then like go back to the root and like do all this fancy transformation to get back to like the meaning of the word. So I'm wondering if that what that looks like if you're using a language like Chinese where everything kind of has a meaning within the kanji or like.
Yeah.
You know what I mean?
Yeah, definitely. So the question is, do different languages call for different types of NLP methods, for example? And there's very large differences. So Chinese and several other East Asian languages, there's no spaces between words. There's lots of easy algorithms you can do with English if you rely on spaces. Like I want to know the word counts, the count of how many times a word occurs is very easy to get that. It's non-trivial in Chinese, right? All sorts of things like that. It does depend on what sorts of NLP models you're doing. I think what you described of looking at kind of the morphology of a word, maybe looking at the affixes, the prefixes, and the suffixes, which maybe have grammatical content to them. That's a linguistically aware natural language processing method, and that probably has to be customized for every language. And in Chinese, it works very differently than English, right? Between highly related Indo-European languages, there's some commonalities, then get very different when you go to something else. Yet another funny thing about neural language models is that they seem to work pretty well with very little language-specific linguistic tuning of the preprocessing. It certainly matters on some level, and there's plenty of places where it happens, but the core of the representation is trying to automatically learn the dependency structure between words in a sentence. And this is kind of a classic thing in linguistic typology that in different languages, an SVO language, an SOV language, et cetera, et cetera, et cetera. What seems to be happening for these models is that they need to figure out how to predict the next word or somehow how to get information to make some inference about, I don't know, the answer to your question or something. They have methods that try to figure out which words to more heavily draw information from. The patterns of what words they use sometimes follow the grammatical structure in the language. Sometimes it looks like there's connections that are based on, the subject-verb relationship, for example. Not always. It's a neural net. It's all mixed up. It's terrible. But in principle, if you had a model that was very agnostic about languages and had the correct structure to do this for the class of languages that humans can know and understand, which, no one's quite defined that exactly, right? You could imagine that's just going to learn the grammatical system for any language by itself. And that's kind of the pro-neural LM view. Given a lot of the successes, I have to give it some credit. It could be the case. But there are certainly lots of cases for many types of NLP models where being a lot smarter about having language-specific linguistic preprocessing helps a lot, for sure. I guess the answer is it depends. Great. There you go. All right. Let's finish up. I don't know, random thoughts, but we have this deep social embedding of the natural language processing research and development. And there's so many issues that are going on, but these really affect the natural language processing, and maybe not necessarily the cultural biases and the representations or something like that, but certainly in the types of technologies you expect to see or not see. So the institutional resources for computing data access and the sometimes laborious issue of doing the engineering for these things. Like you have to, try 10 different learning rates and do a search over this, and your job really can be full-time to do stuff like that. It's quite complicated. And that's just a lot of money. You need a lot of money to do it, and that is just a really large issue. And this is a remarkable change in NLP research in the last maybe 10 years or so. It has changed and become a capital-intensive science. So especially when I was in grad school, or if you read even older papers from 1990s or something, it's just one student with one computer that's kind of slow. They run an experiment overnight, and something interesting happens, right? It's very different now. You're seeing papers with dozens of co-authors or whatever. It's just a large effort. It's more like big money sciences and physics or something like that. I think it's very new to the areas of natural language processing or computational linguistics. I think people don't necessarily know how to do it in academic contexts yet. The funds aren't always there, and it's really being driven by companies, either for-profit companies, or in this case, we have these foundations or nonprofits that are drawing funding from the tech world. I think it's a fair way to characterize OpenAI personally. They might disagree, I don't know. And so it's not inevitable that we have to give it up to just companies and just use whatever outputs they decide they want to share. It's really possible to have a significant government funding program in order to do this type of research. There's been some talk about doing this. I don't know the state of things. It has not happened a lot yet, but this absolutely happens in physics and other areas. I would argue this style of large data or large language model research is very important, and it should have that sort of funding. So I don't know, getting that is a whole other project. I mean, it's more of a political project, right? But would be very important for being able to do better research on these language technologies. And I think addressing questions that don't necessarily turn into strong profit motives for, say, contemporary technology companies. There are lots of them regarding cultural heritage, regarding safety, many, many issues. There's so many other issues. The energy consumption of a lot of these models can be quite high. Therefore, the carbon footprint can be very high. That's an area that I think current technical work is okay at addressing. We'll see what happens. I think these things will typically get better, but it is very significant in many cases. We mentioned this before, should we make the models easy to access? Is it safe to release them? Who should get them? No one's really clear on these sorts of things. And just in general, what does it mean to have responsible language technologies? Who gets to decide under what circumstances? We need intelligent conversations about this. What's currently happening, if this isn't done intelligently, is something really bad will happen, and then there will be very clumsy regulation about it, and things will get messed up, and the problems may not be solved, which is bad. And some people complain about, I don't know, has anyone worked at like a company had to deal with like EU regulations on technology privacy? GDPR, anyone? Yeah, I don't know. You've noticed when you go on about 5 years ago, everywhere you go on the internet, a little thing pops up saying whether or not you accept the cookies. That did not exist about 5 to 10 years ago. So that's from the EU regulation that went in. And I don't know, my friends at tech companies complain it's overbearing or whatever. But I think that sort of thing, the privacy of user data is important, but it's kind of in some ways small stakes for these like kind of weird, highly automated things that we don't super know how to do and what we want to steer them to do. The easy answer is we need more research on this, but we need more research on this. I think we don't know. Okay. All right, so, I'm going to conclude here. I had a whole other half of my talk. I'm sorry. We didn't get to it. I prepared too many things. But we have all these different ways for social factors can affect natural language processing. We mentioned maybe a few of these things, kind of the implicit information interactions and kind of the cultural biases that go in, the institutions that help us create the language models, NLP technologies. I just want to make the point that all these social factors are incredibly important for all AI systems, especially AI systems that involve training or model fitting or adaptation to human behavior, which seems to be the best way to make at least language and vision systems. This is super, super, super important to pay attention to. Okay, thanks. I think we have time for more questions. Sorry, I think your hand was up first. Yeah.
I was wondering, would there ever be possibility of actually basically inserting AI into the human body? So
Sure. Yeah.
you could think and activate AI.
Sure, possibility of embedding AI into the human body. Sure. Yeah, brain-computer interfaces, people have talked about. Our brains have adapted to smartphones, right? You're not putting your brain, but you're putting it really close to your stream of sensory knowledge. And our brains totally work differently now that we use smartphones, right? I can imagine lots of other things. I don't have any smart thoughts about that though, but yeah.
I want to say, first of all, I love the bidirectional arrows there, and that, in relation to ILA, is one of the things I always want to emphasize, that it's a multi-way interaction. It's not just
Great, yeah.
technology going out or being used, but multi-way interactions. And I wanted to ask you a particular question about natural language processing and good old-fashioned cognitive science, linguistics view of that field, and what you think these multi-way interactions look like. Two quick thoughts are, one is that somebody might say, oh, the Chomskyan view is not really right because look, these things can learn language incredibly well just from data without real cognitive structure that the Chomskyan view says has to be built into the human language organ. But on the other hand, you could say, well, it's getting a lot more data than a baby gets, right? It's getting
Right.
So that's like a first glance at it, but you're much more deeply immersed. I wonder if you have thoughts about how this should influence the view of cognitive science and linguistics about the nature of the mind and language.
Yeah, so it should have a significant influence, I think. Exactly what the propositions are, I think it's always tricky. There's a really good review/rant by Piantatosi, I think is his name, computational, maybe more of a psycholinguist. The title is literally Large Language Models Disprove Chomsky's Generative Grammar. It's a very good review of a lot of the results I was kind of mentioning, I think. No question, they can induce structure. There's lots and lots of evidence that induce structure that looks a lot like syntax in various ways. Exactly how it's done is unclear. There is maybe bleeding edge research that is trying to investigate computational models as cognitive models by, for example, creating a data set that is approximately similar size to what humans typically experience up to age 12 or adulthood or whatever. I think the data sets, there's a lot of trickiness, of course, in doing these sorts of experiments, but they seem very important for that, absolutely. And I mean, it is complicated. Like some of these neural architectures are more cognitively plausible than others. The ones that seem to be most successful transformers are weird. Recurrent neural networks look a lot better, so people are interested in that. And so there's always going to be these conflicts between engineering or not. And there's lots of, more boring technical engineering reasons for the particular architectures that are here. But I think there's no question we need to be doing something that looks like this, looking at like structure induction or automatic learning, and to investigate on the cognitive side. Absolutely. I mean, they wanted it in the 1980s. That's what the connectionism movement was about. So I didn't mention, I showed that thing from 1989. A lot of the research that went into that was from the perspective of better models of human psychology, because humans have artificial neural networks. Lots of animals do, and they really do distribute information in a way that we don't necessarily understand. Maybe you all have heard this from Lee a lot in his classes, I don't know. But it's crazy. It's pretty amazing that animals can learn these things, and people want to make computational models of it. But now, of course, it's been deployed as this purely commercial engineering thing, which is, I don't know, in the liberal arts, maybe we should try to do something better. But you see why people wanted to do it that way, I think it's fair to say.
I think we have time for one or two more questions.
I think you just were waiting. Yeah, go ahead.
Yeah, I'm also I was also reading and looking at Chomsky's argument and kind of thinking about a lot of what's kind of talking about in the presentation about how the way that the artificial intelligence behaves is related to how we're training it. And I was curious if I was kind of considering on my own that we find that there are these results where we're feeding it these very large data sets of human text as it appears on the internet. Then it's spitting back these horrible, horrible things. And then we're having to go in and tell it kind of mechanically, almost in a authoritative, maybe religious or Kantian manner, no, you can't do that, that's bad, we don't want you doing that. And then the computer kind of adjusts and says, oh, okay, I won't do that anymore. But I was kind of curious, kind of genuinely considering that, the implications back into social sciences and humanities. Can we say that maybe the AI, the fact that it's producing this behavior is telling us something about the way that our societies, that there happens to be at least on average, on large average, perhaps on the internet, maybe the internet's a reflection of society, that people are engaging in really violent, not logically coherent, hallucinatory behavior, and then AI
So, yeah, I mean, it's teaching us some things. I think they're having behaviors that really don't conform to typical human thinking or behavior sometimes. They're really crazy just making up facts. Some people have tried to, I don't know, there's a lot of speculation about how to think about that. I think you need to do a lot more controlled analyses with known corpora for this sort of thing. I've done a lot of work in the kind of the more computational social science area where we have a very specific corpus. News articles from 1990 to 2010. I'm going to use a particular language model that is not the type of neural LM. It's a much dumber model, but it's a model that can give us insights about what's going on. For example, clustering or learning trajectories of ideology or sentiment, things like that. And I think that's really great. That teaches about the corpus. What's fun about LLMs, it's simultaneously trying to build as sophisticated a model of human intelligence as possible from this notion of general intelligence. What does that mean? It's unclear. But at the same time, it's giving us a model of what's in the corpus. And it's a fuzzy view of what's in the corpus, right? And so it's really unclear how these things are mixed. And it's hard to access the corpus. We just have access to the parameters, or an API where we don't even have access to the parameters, right? So it's very confusing, I think. So it'd be better for someone to do research in this and clean it all up. So you all should do that if you want.
We're losing a lot of people, and that's a great place to end. So let's thank our speakers.
Thanks.